Hey everybody, let's go ahead and finish the study guide here today. And we're going to start off with problem 18. Our objective is to solve for x. And so I'm going to go ahead and condense to a single log on the left-hand side. We will write as a single log and then use the definition of log to write an exponential equation which will enable us to solve for x, isolate that x value. So let's go ahead and first use our power rule and then use our quotient rule after that. Okay, so here we have our power rule. Next thing I'm going to use is the quotient rule, and I'm also going to rewrite a 1/2 power as the square root. So let's do two steps at once here. Alright, so we've condensed into a single log by using the two rules. Now I'm going to rewrite this logarithmic equation in terms of an exponential equation. Remember that the log has a base of 10. So we're going to say that 10 to the first power is equal to the quantity x divided by the square root of x plus 4. Okay, so now we're at the point where we can start simplifying this entire equation here. We're going to start off by multiplying both sides by the denominator square root of x plus 4. Let's go ahead and do that. Okay, so I've multiplied both sides by the denominator, and now we have a modified equation. And my goal is to somehow solve for x. And so I want to pull that x out of the square root there. And so in order to do so, I'm going to raise both sides to the power of 2. So now here we have 100 times 100, which is, 10 times 10, which is 100. And then we have the square root of x plus 4 times the square root of x plus 4. So we end up with just an x plus 4 coming out of there. And that's equal to x to the power of 2. So let's go ahead and distribute in that 100 and pull everything to one side. And we're going to see a quadratic in which we can solve for x. Okay, so here we have this quadratic, and we can't factor that. So in order to solve for x, we're going to have to use the completing the square method or use the quadratic formula. Whichever one works best for you. They both give the same exact answer. So I'm going to go ahead and erase a few things and get it started here. Hold on. I'm going to use the completing the square method. So that means I'm going to start off by pulling the 400 on the other side. So we're going to have 400 equals, and then we're going to take half of 100 to the power 2, add that value to both sides. Okay, so now on the left side, after we've taken half of 100 to the power 2 and added that 2500 to both sides, now on the right side over here we have what's called a perfect square trinomial. So we're going to rewrite that factored into two binomials, multiplied, and on the left we're going to add those two numbers. Okay, so now we have a situation in which we can take the square root of both sides to pull the x outside to isolate that x. And so we're going to end up with, we have x equals plus and minus the square root of 2900, and we have a plus 50 here. Okay. Alright, so let's see if we can't simplify that square root of 2900. Alright, so we have 50 plus and minus square root of, that's 29 times 100, and the square root of 100 is 10, so that gives us 50 plus and minus 10 root 29. Alright, so let's think about this further if we have to eliminate one of these values here. Alright, so our only answer can be 50 plus 10 root 29 because 50 minus 10 root 29 gives us a negative number. So if you think back to 50 minus the square root of 2900, I knew that that was negative because 2900 is larger than 50. The square root of 2500 is equal to 50. So that means that 50 minus the square root of 2900 would give me a negative number. And that's okay, but when I substitute that negative number back into the original equation, specifically log base 10 of x, I end up with something that doesn't make sense. For instance, log base 10 of a negative number equals what? Question mark. So we say 10 to some power, 10 to the question mark power equals a negative number. Is that possible? No, 10's positive. 10 to some power, whether it's positive or negative, whatever, is not going to change the actual value of the base 10, right? The sign of the base 10, right? So 10 to some power is always going to be a positive number. It's never going to come out negative. So that situation can never work out to make sense. So we have to eliminate that negative answer. All right, so let's move on to the second question here. That took us a long time. Okay, so on this problem here, what we want to do is to solve for x, and so let's see here. We could actually solve this a couple different ways. We could choose to pull all the logs on one side of the equation and condense into a single log, and then use the definition of log to rewrite into an exponential equation. I think that's a lot harder than using the one-to-one rule of log. So what my objective is now is to condense the left side into a single log, and then use the power rule on the right side, and then use my one-to-one property for logs. Let's go ahead and use the product rule on the left and the power rule on the right and see what we got from there, okay? Okay, so at this point here, we're like, well, in order for this to be a true statement, whatever is right here and whatever is right here has to be equal to each other. Those two quantities have to be equal to each other. So we can simply set those equal to each other and solve for x. So let's go ahead and do that right now. All right, so we have our equation here, and we have to solve for x. So let's see here. I'm going to go ahead and pull the 19 on the other side, and then can't factor, so quadratic formula, complete the square. It's up to us. Let's do the quadratic formula this time. All right. Okay, so I've identified my a, my b, my c. Use the quadratic formula to come up with x equals minus 3 plus and minus the square root of 85 over 2. And we can't simplify the square root of 85. That's 5 times 17. So we have no doubles there. What we have to do at this point, though, is eliminate one of our answers. We can't use minus 3 minus the square root of 85 over 2. Okay, so our only answer is the one that I have circled there. The reason why we can't use the minus is because, remember, the square root of 85 is actually a number that's greater than 9, right? Because the square root of 81 is 9. So that means that whatever that is going to be approximately negative 12. And negative 12 divided by 2 is going to give us a number like negative 6 point something, so less than negative 6. And if we were to plug in a value less than negative 6, even negative 6 itself would give us, up top here, looking here, would give us a log base 10 of a negative number, which just won't work. So we can only use one of those solutions. Alright, one of our favorite problems here. We want to start this one off by pulling all the terms to one side. So I'm going to multiply both sides by 2 and then pull the 16 on the other side. Okay, so now what we want to do is manipulate this into the form of a quadratic, and the way we do that is by multiplying both sides by e to the x power. Let's multiply both sides by e to the x and see what we get. When we have the same base like we have here, we can add the exponents. We're multiplying with the same base, so we add the exponents to give us e to the 2x. Same base, add exponent, so we have an e to the 0 power, e to the x times negative 16, and then 0 times anything is 0. So let's go ahead and rewrite our problem a little bit. We know that e to the 2x is like saying e to the x to the second power. E to the 0 power is a 1. So I'm going to pull the 16 minus 16 e to the x in the middle, and e to the 0 power is a 1. And this is starting to take the shape of a quadratic. In fact, let's go ahead and let e to the x equal y. Let e to the x equal any old variable. I'm using y. And then from here at this point, we're like, oh wow, this really looks like a quadratic. We can solve for y. And then once we've solved for y, we can resubstitute back in e to the x and solve for x. At this point here, I can't factor, so I'm not going to use the quadratic formula. I'm going to go ahead and complete the square. Pull the 1 on the other side, so it's going to give us a negative 1 on the right, and take half of negative 16 to the power of 2. Okay, so we have pulled the 1 on the other side. We have a negative 1, and half of negative 16 to the power of 2 is 64. And that gives us a perfect square trinomial on the left. And so we can break apart into two of the same binomials. So we have y minus 8 squared is equal to 63. Alright, so from here, let's go ahead and solve for y. I'm going to erase some things. Alright, so what I've done is I've taken the square root of both sides and added the 8 to the other side. And so we have y equals, and we're not interested in y, we're interested in x. So I'm going to substitute back in what y is equal to. It's e to the x. And I'm going to solve for x. And the way I'm going to solve for x is by taking the ln of both sides. Using the taking a log of both sides enables us to use the power rule of logs to bring the x in front of the log so that we can solve for x. Okay, here, so we have x times the ln of e is equal to the ln of 8 plus and minus the square root of 63. Remember that the ln of e is equal to 1 because e to the first power is equal to e. ln is simply a log base e. So we are left with x equals the ln of 8 plus and minus the square root of 63. And I don't think I'm going to have to eliminate an answer here because the square root of 63 is less than 8. So that doesn't give me a negative number to worry about in this case. What I'd like to do here right now is show you guys how to check on the calculator. Let's make sure that we're right. Alright, so I've typed in the ln of 8 plus the square root of 63, and I get that decimal answer. And so I'm going to plug in that decimal answer into my equation to make sure I'm right. So we have e to the x, so that x is our answer. I'm going to hit second negative, which gives me my answer. We have e to the x, and then minus e to the negative x. Negative answer, and that's divided by 2. So let's go ahead and hit enter, and then divided by 2, and something's not coming out right here. Let's try the other one. Let's see what happens with the other one. The ln of 8 minus square root of 63. Alright, so I'm coming up with something that's pretty close that's not right though. So I must have made a mistake somewhere in the video, and I'm not going through this whole darn video again. I will, however, in the next video show you the work and Gosh, there just might not be an answer for this one. Here, let me see in the next video.